we have a frame. Actually, I don't care in this course. I don't care about the type of the structure, beam, frame, or truss. My first concern, what type of supports do you have? Please read your problem carefully. This frame is roller supported at A. So A is a roller. So we have only one reaction, this reaction perpendicular to the base of the roller. So we have YA. It's roller. And this frame is pin supported at D. So D is pin or hinge. So we can expect two reactions, one vertical and one horizontal. You can assume any direction, to right or to left. For the vertical reaction, up or down, it's up to you. So the vertical reaction, I'm gonna call it YD. The horizontal reaction will be XD. Please go ahead and calculate the reactions. Before starting, we have something here called uniform distributed load. Can you watch it? With 8 feet length, 2 kb per foot value. So I'm gonna convert it to equivalent like this. Do you remember where? At mid distance. So 4 feet from this side and another 4 feet from the other side. Mid distance for the 8 feet. What is the value for this equivalent force? It will be the value of the distributed load 2 times the total length of this distributed load 8. So 2 times 8 will be 16 kb. So go ahead and apply your equilibrium equation one by one. The first one, summation of all forces in x direction equals 0. Please be organized. So I need to apply, to write first the equilibrium equation, then go ahead and substitute in this equation. What forces in x do you have? Please don't forget any. What forces? We have positive xd at the reaction. Why positive? To the right, so it's positive direction. What else? We have negative 3. What else? Do you think we have another force in x direction? No. So equal 0. All of these forces equal 0. So xd will equal 3 kb. And here is the first reaction. Second equilibrium equation, summation of all forces in y direction equals 0. What forces do you have in y direction? We have positive YA. We have positive YD. We have negative 16. We have negative 4. Please don't forget any. We have positive YA, we have positive YD, we have negative 4, we have negative 16, nothing else. Equals 0. We have two unknowns. I cannot do anything. Just simplify this equilibrium equation or this equation. YA plus YD will equal 20. And I can call this equation number 1. The third tricky equilibrium equation, summation moment at any point equal to 0. Do you remember? Summation moment at any point equal to 0. I told you a recommendation. Take moment at supports. Actually, we have two supports, A and D. Go ahead and take moment at supports with the large number of reactions. I think I'm gonna take moment at D. Guys, this equation called summation moment at any point. You can take moment at any point as you like, but I recommend to take moment at support. And I highly recommend to take moment at the support with the larger number of unknowns or larger number of reactions. So I'm gonna take moment at D and assume counterclockwise is positive. Any other direction will be negative. Just to remind you, guys, moment equal force time distance. Your force and your distance must be perpendicular. Any force need distance to make moment. Okay, so taking a moment at D, xd times 0, yd times 0. We don't have distance for these reactions. What else? 3 times 15, positive. What else? 4 times 0. Wow. 4, the distance between this force and this point is 0? Yes, because this force is vertical force. So I'm looking for horizontal distance. Do you think we have horizontal distance between this force and this point? No, we don't have. Keep going. Plus 16 times how much? 4 plus 4, 8. What else? Negative YA times the total distance is 12. Nothing else. I'm done. Equals 0. Remember, this term will be cancelled. This term will be cancelled. The only unknown in this equation is YA. So I can figure out the value of YA. It will be 3 times 15 plus 16 times 8 divide 12. This value will be 14.4 kip. So I can go back to put this value 14.4 to figure out the value of YD. YD will be 6.6. I'm sorry, 5.6. So finally, reaction YA equal 14.4, YD 5.6, XD equal 3. All of these values are positive. Positive, that means you assumed the correct direction. Any questions so far? I think I didn't do too much for this problem. For this one, it's very easy. Nothing new except one comment here. We have something here called two-force strut, BC. By the way, we have a beam. This beam is supported at A by pin. So A is pin. And this beam is supported also by two-force strut. Can you watch this member? This member is a special member. The problem said this member is strut or two-force strut member. CB. We need to determine the reaction at A and the reaction at B. So if you have a strut member, in your beam or your structure, whatever the type of the structure, go ahead and remove this member. Go ahead and put only one reaction in the same direction of this member. We have two rules here. These two rules only if you have this type of members, two-force strut. So first step, you need to remove this member. That means your beam will be looks like this. Here is the hinge A. Here is point B. Here is concentrated load 800 Newton. Concentrated moment 900 Newton meter. And uniform distributed load, how much? 600 Newton per meter. And we have concentrated load here, how much? 600 Newton. So first step, I removed this member. Second step, put only one reaction. So at this point B, we have only one reaction. So this one reaction is a horizontal reaction, is a vertical reaction. What is the direction of this reaction? This reaction will be in the same direction of the member. So your member looks like this, your reaction will look like this. Or this point is very important. If you have a beam looks like this, and your member like this member AB, for example, is 2/4 strut member. So go ahead and remove this member. Here is the beam. So at point B, I removed this member, and I'm gonna put one reaction, only one reaction. Which direction? Vertical or horizontal? In the same direction of the member. In this case, your member is vertical. That means your reaction will be vertical. If your member is horizontal, your reaction will be horizontal. If your member is inclined, your reaction will be inclined in the same direction of the member. Any question for this point? Any question? So please pay attention if you have 2/4 strut member. If you have this member in your beam, please go ahead and remove this member, put only one reaction in the same direction of the member. We have here two reactions. It's pin or hinge. So we have XA, we have YA. We have here uniform distributed load. So we have equivalent. How much? How much? 600 times 2 meter. It will be 100 or 1200. I'm sorry, 1200 or 1200 Newton. Guys, we have something here we need to adjust before going. We have inclined reaction or inclined force. We need to figure out the horizontal and vertical component. Do you remember? So if you assume this angle is theta, the vertical one will be R sine, the horizontal one will be R cosine. We are good. This angle theta that you assumed in this right angle triangle, that's right. We have here right angle triangle, this one. So this length is 2, this length is 1.5. So I can figure out the length of the third one will be 4 plus 1, which is square. It will be 2.5. So I can figure out sine and cosine. So sine theta will be 1.5 divide 2.5. Cosine theta will be 2 divide 2.5. So this sine and this cosine, I can figure out these values. Okay, we are ready. We are ready for equilibrium equation, summation of all x equals 0. What do you have in x direction? We have positive XA. We have positive R cosine theta. What else? Do you think we have any more forces in x direction? I think no. XA and this component only equals 0. We have two unknowns, XA and R. I cannot do anything. This problem or equation number 1. Summation of all forces in y direction equals 0. We have positive YA. We have negative 600. Please don't forget any. We have positive R sine theta. We have negative 1200. We have negative 800. This one, this one, this one, this one, and this one. Nothing else equals 0. If you look to this equation, we have two unknowns, YA and R. I cannot do anything. I cannot do anything. So go ahead and apply the third equation. The third equation, summation moment at any point equals 0. Guys, do you remember my recommendation? Do you remember my recommendation? Take moment at any point. This is the equation, the third equation. But my recommendation to take moment at support with large number of reactions. So I'm gonna take moment at A. I'm gonna assume this direction, which is clockwise, is positive. So go ahead. XA times 0. YA times 0. 600 times 1. Then R cosine theta times 0 plus or minus, I'm sorry, should be minus, R sine theta times 2 plus 1200 times 3 plus 800 times 4 plus 900 times what? Equals 0. First question, my first question. Please pay attention. My first question. Why R cosine theta multiplied by 0? We have here a horizontal reaction. Horizontal component. Do you think this component at this point does not have any distance to point A? Yeah, we don't have distance. Why? Because you are talking at point A, and we have here horizontal component. This horizontal component need vertical distance. Your force and your distance must be perpendicular. Do you think we have vertical distance between this point and this point? No. Both of them at the same line are collinear. So your distance is 0. Do you have any comment? My second question, and I need answer. My second question, and I need answer. What is the distance for 900? 900 is this moment. And I'm sitting here at A. What is the distance between 900 and A? So what should I do here? What should I put here? Any answer? Thank you, guys. Thank you so much. Yes, all of you are correct. Mitchell, you are correct. John, Jordan, Anthony, all of you are correct. Yes. And be careful during the exam. Be careful. We don't have to put here a distance. We don't need a distance. This one is very tricky. 900 is a moment. If you have already moment, you don't need distance. Just put it. without any distance. The only unknown, this one will be cancelled, this one will be cancelled, and this term will be cancelled. The only unknown in this equilibrium equation will be R. Remember, sine theta equal 1.5 divide 2.5. So the only unknown will be R. So I can figure out the value of R. Once you figure the value of R, I can go back to this equation, put your value of R, and the cosine theta is 2 divide 2.5. So the only unknown will be XA. So I can figure out the value of XA. Go back to this equation. R is known. Sine theta is known. The only unknown in this equation will be YA. So I can figure out the value of YA. Then your problem is done. So the tricky or the hint in this problem, if you have a strut member, if you have two force member or two force strut member like CB, please go ahead and remove this member and put only one reaction in the same direction of this member. Remember, if this member is vertical, your reaction will be vertical. If this member is horizontal, your reaction will be horizontal. If this member is inclined, your reaction will be inclined. Because the reaction in the same direction of the member. In the same direction. Any question? Okay. The last thing I need to cover, it's very simple for this problem. We have Pulley. Do you remember if you have a Pulley, what should I do? If you have a Pulley and you have rope or cable around this Pulley, this force will be the same like this one. That means this beam, if you would like to redraw it, we have here a force F will be the same like this one. F. Why? Because the same cable going around this Pulley, so this force in this side will be the same like this side. And we have hinge here at A, so we have two reaction, XA, YA. We have vertical force here, how much? 800 Newton. So I can apply summation F of X equals 0, summation F of Y equals 0, summation moment at any point, I'm gonna select A equals 0, so I can figure out the value of YA, XA, F, or F, both of them the same. So the only tricky in this problem, just to remember, we covered this before, I believe. If you have a Pulley, that means the force in this side will be the same value like this one. But this one will be vertical, and this one will be inclined following the direction of the rope. But the same equilibrium equation.